Hello, this is Damian, and today I'm going to talk about one of my favorite buddies, the Mazda GTC nose. As you can see, I have a lot of experience with this nose, and what I'm going to do is show you how you can tell between an original Mazda GTC nose, a petted version of the nose, or a cheaper knockoff version of the nose. Also, we're going to talk about some improvements we can make to the nose for those organizations that are looking to remake the nose in a different type of material than fiberglass, and add in some of the improvements that I'm going to show you later in this video. Let's start with an original Mazda GTC nose. Now the original is always going to have this hole in the front. Now a lot of copies also have this hole in the front, but if it's an original Mazda GTC nose, you know it's always going to have this hole in the front unless it's been worked on after it's come from Mazda. Okay, now we're going to talk about the slope of the nose. This is the angle in which it sweeps down from where it meets the hood all the way down to the front of the nose and spans between the lights from side to side. Now, on a good quality nose or an original GTC nose, this slope is almost a straight line. It doesn't have any curve to it, right? And that's how you know it's either a very good quality copy, like a petted copy, or an original nose. A very poor quality copy will have a dip to it, and that causes fitment problems with the hood, as well as bows the corners or bends the corners up away from the lights, causing more fitment issues. But if this line is very, very straight, then you know you have a good quality copy or an original GTC nose. Okay, here is a poor quality copy of the nose that I have on the race car right now. And I want to go back to that slope in the front that I was talking about just a moment ago. This one, as you can see, it doesn't have a straight line slope. It's slightly indented right in the center here, in the center area. It goes in towards the car, and that forces the corners to go upwards, causing poor fitment in the corners to the lights and also to the hood. Sometimes it also causes a slight sagging in the center, causing a separation to the hood. The petted and the original will have a nice straight slope there. Poor copies will have an angle there, and as you can see, it comes up in the corner, causes fitment issues, things like that. Another thing to look at is the blinker housing. If it doesn't have the flanges molded in to hold the blinker assembly to the bumper, that means it's probably a poor quality copy. The Mazda GTC original and the petted copy, and other good quality copies, will have the flanges built in. I'll show you that right now. So here's an example of a petted copy that has the flanges built in to hold the blinker assembly. You can see them here. Now I'm going to talk about an obscure part of the nose, the bottom of the nose, on the front lip. The bottom front lip on an original GTC nose, or a good quality copy like the petted copy, tends to be longer than on a cheaper copy of the nose. For example, this distance here, on the cheaper copy that's on my current car, it's about half this length. And that's just another thing you can look at to help you determine whether you have an original or a good copy versus a cheaper copy of the nose. Now let's talk about what we can do to improve the current GTC nose design. The first thing I want to touch on is the brake duct and oil cooler entryway. Let me show you what we do currently. Okay, let me describe to you what you're looking at. This piece right here is actually the oil cooler itself, and this is the nose. One thing to notice here is that I use the stock oil cooler ducting to mate up with the GTC nose. Now we have to do some modifications to make that happen. As you can see over here, there's a small slit where the nose can fit into that slit, but you lose about 1 inch to 1.5 inches of airflow going to the side of the duct. Now some of the air still makes it over there. However, I block off this side so it can't get out the side, but a better design would be to extend this wall all the way to the end of the oil cooler so that you get the full airflow going all the way through the oil cooler without having to do this intermediate ducting step. Now that means extending this wall of the nose further back at the proper angle to mate with the oil cooler, and also extending this wall of the nose over here outward further to mate with the side of the oil cooler. I'll show you another angle down here. Now, as you can see, I have some mesh there just to protect the brake ducting entry and the oil cooler entry, but this is the side wall that I'm talking about. They could be extended inward. Now this line wouldn't change. You wouldn't want to change this line right here. However, you would just take this wall and make it so that it goes backwards more towards the back of the oil cooler. Instead of angling this way, it would actually angle that way, mating with the back of the oil cooler. Now, this wall also, for brake ducting, should be moved backwards and flattened. That way you can get a full brake ducting hole here without having it cut off. As you can see here, my brake duct in the back gets cut off by this bend right here. Same thing with this wall in the bottom. It'd be nice if we could take this wall and bend it down so that it ends up going more of a straight angle in and mates with the bottom of the brake ducting. Now, later on I'll talk about merging all this into the actual nose, because that would be ideal, is if we could get the actual brake duct molded into the nose so it's all one piece into a nice brake duct. Here's the same shot, but with the oil cooler duct removed so you can see the gap that's there. Now, an improvement would be to extend the nose material so that it gets very, very close to the oil cooler itself. You don't want it touching, or you could extend it so that, you know, it just needs to be trimmed a little bit, and then you put foam or something there to protect the oil cooler. Also, the angle of this would have to start to bend out to meet the end of the oil cooler here, so that way you get full coverage of the oil cooler. Also, you can't see it from this angle, but this wall of the nose is slightly lower than the top of the oil cooler. So as the material would extend out, it would have to come up, it would have to elevate to meet with the top of the oil cooler. Here's an angle from the front, and as you can see, there's a dilemma here because the oil cooler fittings take up some space where you want to put your brake duct. Now, the way we manage that now is we cut a slot in the brake duct shape so that it fits in there properly, but you lose a lot of flow to your brake ducts. It's hard to articulate some of the changes that I'm talking about with this shape here because it's in 3D space. So I'm going to try to show some of the things that I'm talking about here using this nose that I've put some cuts in so that I can push some of the walls of the nose around to show you what I'm talking about. One of the main things is trying to get more space to the brake duct area, which is the bottom part of this space. And one of the ways to do that is by taking this bottom wall of the nose and moving it so that the angle is less vertical and more flat. This whole wall would actually go down like this and give you quite a bit more space for the brake ducting. Now that means you'd have to mold in the sides and get the shape rounded nice in the corners, etc. But this whole wall should actually be pushed down almost parallel to the bottom part of the nose down here. Now another change would be this wall right here. We actually want it to be less inward towards the car and move more outward towards the edge of the oil cooler so it doesn't cut off the oil cooler like I showed previously in the video. So we actually want these walls to be angled inward like this. And another change would be this bump right here. It's in the original design and I'm not sure why. And all it does is block off some flow that you could get to a nice brake duct here. So remaking this wall to not have this bump right here and have it further in so that it matches the side of the oil cooler gets you a bigger space here for the brake ducting, and coupled with this wall being down further gets you away from the oil cooler connection that blocks the airflow to your brake ducting. That allows you to put in a much better brake ducting space here, and if you can mold it into the nose, that'd be even better. Now another change to the nose involves the angle of the bottom of the nose. And there's two parts to that. One is the overall angle that the very bottom shape of the nose makes, and also the very, very corner of the nose, and how that affects adding a splitter or some other aftermarket under tray type piece. Let's take a look at what I'm talking about. First, I'm going to talk about the simple part. Here, if you look at the corner of this nose, I've already made a modification to it. The stock mold, whether it be a copy or the stock GTC nose itself, the corner of it actually comes down here, lower than what you see here. And what that does is it makes a non-flat bottom to this corner. So mounting something like a splitter or an under tray is very difficult, and the under tray wants to end up pointing upward, which is exactly what you don't want. Now if you see here, what I did is I cut out a small corner of the material and brought the bottom of it up and then bolted a little bracket here to hold it together. Now that's kind of a intermediate fix to help solve the corner, and it does help adding an under tray, keeping it flat, but what it doesn't solve is the bigger problem, which is this. See this triangle shape here that this makes on the corner of the nose? The problem is that the triangle shape is in such a way that this bottom is not flat when it's on the car. It's at a slight, very slight angle upward. Now, what that causes is that when you put an under tray on, again, it causes a slight upward angle to the splitter or under tray. Now, the way to solve that, at least in a simple sense, is to create some sort of spacer, which I'm looking into, that would give a very thin spacing here at the corner and slowly, gradually get thicker as it gets to the front of the nose so that the under tray splitter can sit flat. Now, a real solution, which is more difficult, and I don't know if it's even possible, is to actually redo the mold for the nose such that this bottom triangle shape ends up flat when it's on the car. Now that means one of two things. You can either take this whole shape and in the new mold rotate it so that this is a slightly more angle up and this ends up being at a flat angle, or you would have to just basically eliminate a section of this area and draw a line straight across, and that whole part of material would just have to be eliminated from the nose. Now the problem with that is that you end up making it slightly higher, which you may or may not want depending on the height of your car, etc., etc. But that's the issue with the angle of the front, and I'm not sure if it's possible to fix by creating a new mold or things like that, or how difficult it would be with the people that are creating a new version of the nose. But ideally, it would provide a perfectly flat bottom to mount an under tray or splitter on. I think more realistically is if they can just get this corner fix into the mold, that would be enough, and then we can mitigate it with some sort of spacer or something like that in the front to manage getting that splitter straight. That about sums up my notes on the GTC nose for now. Feel free to post questions or comments or suggestions in the thread on the RX-7 forum in which I post this video. And I'm really excited to see the organizations that are going to remake the nose, what they do and the changes they incorporate, and also having it in a different material than fiberglass so that they can take the dings a little bit better and not chip up so bad, etc., etc. Hey, look who signed my car. Randy Popst.